So I'll start off with arithmetic progression now. So we will discuss about AP, GP, and what I'll do is I'll basically discuss the concept of AP, GP today, and then we will move on to percentage, average, simple interest, compound interest. All these concepts will be discussed today. Then we will start solving the questions in the second session of today, right? So the agenda for today's session is basically I'll try to complete AP, GP, then average, again simple average and weighted average. Then we'll also discuss about mixtures, alligation. Okay, all these will be covered together. After that we'll discuss about simple interest, compound interest, all those topics. Then in the next session we'll try to take up the problems and we'll solve all the problems, right? We'll also look into the previous CAT questions as well as the possible questions which can be asked, and we'll also take some of the difficult questions also. So what is I'll start off with AP. What is AP? Like if you write 1, 2, 3, 4, 5, if you write the first 10 natural numbers, it is an AP, right? So arithmetic progression, you see this common difference 1. So all the number in the series is having a common difference 1. Now mostly you will get pattern based questions in AP and GP. You can see a lot of pattern based question. So if you are able to relate it in the first like 30 seconds or something, you solve it. Otherwise it is going to be a difficult question. You will end up in wasting time. Okay, anyway, we will be discussing about some of the important patterns that you can get in such kind of questions also. But if you see this is an AP, right? Now if you take 2, 4, 6, 8, 10, etc., this is also in an AP, right? Because you have a common difference of 2 here, right? Because you have a common difference of 2. Now if you take 15, 10, right? Then 5, 0, minus 5, this is also an AP, right? So here also you can see the difference, right? Difference is 5, difference is 5, difference is 5, difference is 5, right? So this is also an AP. Now what are the possible questions they can ask you from AP? See, they can ask you hardly few questions directly. It's like what is the nth term? They can ask you what is the nth term, or they will give you a set of like numbers, okay, and they will tell you this is in an AP. Sometimes they will give you the first number as well as the last number and the common difference. Then it is not a question, this is easy, direct. You just need to apply the formula last minus first divided by common difference, right, plus 1. That is what your number of terms. Okay, nth term, there is a formula a plus n minus 1 into d. I'm just discussing the formula for the sake of discussing it anyway, right? So just this is the number of terms, this is nth term. Now see, if they are giving a, that means the first term, and they are giving common difference, right? You can find nth term by using a plus n minus 1 into d, right? So if you need to find the 11th term, this will become a plus 10d, because n minus 1, n is 11, right? You put n is equal to 11. So if you need to find t11 or 11th term, okay, you write it as a plus 10d. A, you know, let's take this series 10, 20, 30, 40, etc., right? So this 2 is enough to understand the first term and the common difference, right? What is the first term? First term is 10, so you'll substitute a is equal to 10. Common difference 10d, that means 10 into 10 again, that is nothing but 100. So what is the 11th term? 110. That is easy, right? What is the second way in which they can ask you a question? They will ask you how many such terms are there within a range of 100 or something like that, right? So how will you find the n? If you need to find n, there is nothing but last minus first divided by common difference plus 1. Now there is no point in remembering the formula, but if you can remember this, you may get a lot of questions from this, right? Because this is nothing but a plus n minus 1 into d only. Here you need to find n, right? So what you are doing actually, nth term is equal to a plus n minus 1 into d. You are taking this a, right? So it become n minus a. N means this is tn, right? We are actually finding tn, nth term, right? So this is nothing but tn minus a. That means last minus first, right? Now this d, when it comes here, it will be a denominator. Then d, then this n minus 1. N is what you need to find out, right? So minus 1 become plus 1. So that is what you have written here, last minus first divided by common difference plus 1. So these are two formulas which is required in most of the cases. We have discussed a lot of division questions, right? So there I told you, some of you have already attended that classes. Some of you who joined late, there is no problem. We'll be discussing it again anyway. What are the questions which I have discussed there? I have discussed n is a number. They will not tell you what is a number. Which when divided by 6 leaves a remainder 1. Which when divided by 7 leaves the remainder 1, right? This type of question. So basically you don't know what is n can have many values, right? What is the first possible value? You take LCM, because this belongs to a type 1 category which we have discussed, where the remainder is same, right? When the remainder is same, answer is LCM plus remainder. What is LCM here? LCM of divisors, right? So that is nothing but 42 plus 1, which is 43. So 43 is the first possible term which satisfy both the condition. But there are many such terms, not only one term, there are many such terms which will satisfy the condition, and all will form an AP. That is what most important thing, because you can get a question from there also. Anything which can be asked from an AP can be asked from here also, rather than giving you an AP directly, right? Rather than giving you an AP like 43, 85, 127, etc. Rather than giving this AP directly and asking a question from this, they can tell you that AP, they can define an AP like this, right? They can define the function or AP like this. N is a number which when divided by 6 leaves a remainder 1, which when divided by 7 leaves the remainder 1. Then they can tell you n is a set of natural numbers within a range of 1 to 100 or 1 to 1000 or whatever it is. Then they can ask you any questions. They can ask you nth term, they can ask you sum of terms, they can ask you how many terms are there within a range, etc. Let's see how they are going to ask question. Now how this is going to make an AP? First term we understood 43. Why? 43 is the first number which satisfies both these conditions. When divided by 6 leaves a remainder 1. When divided by 7 leaves a remainder 1, right? What is the next number? If you need to get the next number, you need to add 42. What is 42? 42 is nothing but the LCM of the divisors. And that will be the common difference of the AP, right? So you're going to get a series 43 plus 42k. 43 is the first term, 42 is the common difference, and it's an AP, right? Now any question which can be asked from an AP can be asked here. They can ask you nth term. Nth term means if I am asking 11th term, how will you find? You will find A plus 10D. A you know 43, D you know 42. So that is nothing but 463. Why? 10D is 420 because I know it's 42. A is 43, so I add that 463. So if I ask you how many such terms are there within a range of 500, right? So 1 to 500, how many such terms are there? Now you know already first term is 43. Now within 500, you know 463 is the 11th term, right? If you need to find the 12th term, you need to add 42 again. Then it becomes 500 plus. So you understood that 463 is your last term, right? Otherwise also you can find it. You understood that 463 is the last term. Now your answer is last minus first divided by common difference plus 1, right? How will you do it? 463 minus 43 divided by common difference, that is nothing but 42 plus 1. Now what you'll get? This you'll get as 420 by 42 plus 1, that is nothing but 11. That's what you in fact find out here, 11th term. So this is another question. Now what else they can ask you? If you have a set of such numbers within a range of 500, you know first term is 43, last term is 463. What is the sum of the possible numbers, right? So basically sum of an AP. Now what is sum of an AP? Sn can be represented as n by 2 into 2a plus n minus 1 into d. Okay, so sum you have another formula also, n by 2 into first term plus last term. This is applicable when you know the last term. So here 43 is the first term, 463 is the last term. So you substitute here, you know n is equal to 11, right? So you get the answer. If you don't know the last term, you will apply this, right? You know n is equal to 11, you know n is equal to 11, you know a, right? That is nothing but 43, n is nothing but 11, right? D you know, that is nothing but 42. So in case if you know the last term, you will apply this. In case if you don't know the last term, you will apply this. Now here in this question, which one you will use if they asked about the sum of first 11 terms? If they're asking sum of 11 terms, right? What you will do? You know the first term is 43, you know the common difference is 42, right? So you know this is a series, right? They're asking you sum of 11 terms, so you know n. So n by 2 into a 2a plus n minus 1 into d is the best, because they're giving you sum of 11 terms directly, right? So you substitute this, n is equal to 11, this a is 43, n is 11, d is 42, you will get the answer, right? But if they are not telling you there are 11 terms, they will tell you n is a set of numbers, right? They are just telling you set of numbers within a range of 500. Then you don't know what is n, you don't know the last term also, right? But what you know is last term is less than 500 anyway, right? You know the first term which is 43, you know the common difference which is 42k. Now based on this, right, you need to find the last term which is less than 500, which can come in the series, right? How will you find it? So if you see this, you know that the numbers which can come in the series is nothing but multiples of 42 plus 1, right? So 421 will be one number, right? Next will be 421 plus 42, that is 463. Next will be 463 plus 42, that is nothing but 505, right? So that will not come, so this is the last term. Now after getting last term, what is your formula? N by 2 into first plus last. You need to find the n also. When you have the last term, when you have the first term, you can find n and you can solve it. Okay, that is one way. So what we have discussed, just four things. If it is nth term, a plus n minus 1 into d, right? If it is n, that means how many terms are there, that means n is what you need to find out, right? So this you will represent as tn, nth term. If you need to find n, this is nothing but last minus first divided by the difference plus 1. So this actually from here only. See, if this is what you need to find out, you will apply this. If this is what you need to find out, means you will go for this, right? The same only, you will just change it, right? Now what is sum? Sum is n by 2 into 2a plus n minus 1 into d, in which case n is given, first term and common difference is known. N is given, that means 11 terms or 12 terms or 10 terms or 1000 term which is given, right? You have an AP 1, 2, 3, 4, right? Up to 1000 terms, right? Up to 1000 terms they are saying, it's not given, right? So you know this is anyway 1000, right? So what you will do, you will apply that and you'll get the answer, right? Or if you know the last term and number, right? If you know the last term and number, then n by 2 into first term plus last term. Now what about GP, geometric progression? What is GP? 1, 2, 4, right? Multiples of 2 here I am going to write 8, 16, 32, etc. it will go. So here instead of common difference you will say common ratio. So instead of D it become R. Actually there is no difference, right? So but instead of D you are writing it as R. So what is R here? 2. Here also 2, here also 2, here also 2, here also 2. Or another one which I can write is 27, 9, 3, 1, 1 by 3, etc, 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 right? So what is the common difference here? 1 by 3. Now what is nth term here? If you need to find nth term, if you need to find 100 term or 1000 term or whatever it is, you will just substitute n. So t10, okay, if you need to find t10 or if you need to find tn, if you need to generalize, it is nothing but a r raised to n minus 1. Okay, so what is the change when it comes to GP? See, whatever you are adding in AP, you will multiply. Whatever you multiplied in AP, it will go as power. Okay, so whatever you are adding there, you need to multiply here, right? So that's why earlier you have a plus n minus 1 into d, right? So a and d you were adding. So here a and d, r is actually d only, right? You are multiplying. So whatever you added, this plus became into here. This n minus 1 into d which you multiplied, that became power here, right? So whatever is multiplied become power, whatever is added become multiplication, right? So that is the difference. So what is nth term? A r raised to n minus 1. If it is a t10, a r raised to 10 minus 1, which is nothing but a r raised to 9. So nth term a r raised to n minus 1. What about sum? A into 1 minus r raised to n divided by 1 minus r. Or you have another one also, a into r raised to n minus 1 divided by r minus 1. It depends on the r value of if r is less than or if r is greater than. It depends on r value, right? So it depends on r is less than and r is greater than. So now you get questions like this, right? You might have seen in papers, previous papers, questions like this. You have a square, right? You joining the midpoints of the square, you get another square. You join the midpoints of the square, you get another square. You join the midpoints, you get another square, and it continues, right? And they will give you the outer area or outer side. Let's say outer side is 20, right? So you need to find the sum of all the areas, right? So this is a GP, right? Because area is divided by half, right? So see, this is in this ratio 1:2, right? If this area is 2, this is 1. This is 1 by 2, right? This is 1 by 4, etc. It is going on, right? So if you know the outer area, that is 220 is the side, that means 400 is the area, right? If you know the outer area, that is nothing but it's a GP. This is actually making a GP with a common ratio 1 by 2, right? So sum of infinity is actually a by 1 minus r. So 400 is the a here, first term. 1 minus 1 by 2 is nothing but 800. So now onwards, if you see this kind of question, square, midpoint, midpoints are added, another square, you need to find the sum, means find the just outer area, take twice of it. Okay, so if it is 16 is one side, 256 is the area, your sum will be, total sum will be 512, because 256 by 1 minus 1 by 2, that is nothing but 256 by 1 by 2, that is nothing but 256 into 2, right? So in all these cases, if a square, adding the midpoints and forming another square, keep on adding that, sum to infinity of a GP is what you need to find out. Okay, what is that? A divided by 1 minus r. A is the area of the first square, the r is a common ratio, right? Or instead of a square, you can get a triangle also, right? You're adding the midpoints of the triangle, another triangle, and again you will add like this, right? So here, what is a common ratio? Now if you take one triangle, what they are doing is, you are dividing one triangle into 4, right? You are joining the midpoint, means 1, 2, 3, 4. So what is the ratio? Ratio is actually 1 by 4. The first triangle, outer triangle, and the inner triangle, if you see, the ratio will be 1 by 4. Or this, if you shade this, what is the ratio of the shaded region to the total region? Total, how many regions, equal regions are there? 1, 2, 3, 4, right? 1, 2, 3, 4 equal regions are there. Out of that, 1 is shaded, right? So 1 by 4 is actually the ratio. So what is common ratio? If you ask me, that is 1 by 4. Now this is, keep on adding the triangles here. So this is also going up to infinity, right? So if I ask you, if I tell you the outer area, if I give you outer area A in an equilateral triangle, what is the answer of sum of all the areas? A divided by 1 minus r, right? So what is r here? A divided by 1 minus 1 by 4. There is nothing but a by 3 by 4. There is nothing but a into 4 by 3, or 4a by 3. Now, rather than giving a as area, if you are given a as a side, you know how to find area, right? Of an equilateral triangle, root 3 by 4 a square, right? Now you know, once you get the area, what is the answer? 4 by 3, right? This got cancelled and this become root 3, right? This is nothing but a square by root 3. What is this a? A is a side now. So if the side is given, take square of it, divide by root 3. Now from the option you can pick it faster. Or sometimes they will give you questions like this 4 pi diagram, that anyway I'm going to discuss in detail in GP. Like you have a square, okay, and you have a circle which is inscribed in the square, or they can tell you, you can circumscribe also, this is also possible, okay. But let's start off like this. Then you have like another square which is inscribed in the circle, right? Then you have a circle again like this, okay. You have a square again, right? You have a circle again, and this process is continuing, right? This process is continuing till infinity. The only thing that you need to know here is, right? So square and circle, if you see, the ratio is always 4 and pi. Why it is 4 and pi is because if you take r is equal to 1, r is equal to, the radius of the circle is 1, okay? This is touching, you imagine this is touching. R is 1 means the side is 2, right? So what is the area of the square? 2 square, which is nothing but 4. That is a square, right? What about the circle? Pi r square. R is 1, so which is nothing but pi. So that's why this is 4 and pi. Now whatever you put for r or the side, okay, anyway side will be twice of r, right? If you put 2 here, this will become 8. So if you put 2 here, the side become 4, right? Because that becomes the diameter. Side is the diameter. So the diameter and the side is actually same. So the ratio will remain always as 4 pi. Whatever be the value, you can make the square bigger. Okay. So similarly, you need to change the circle also. If the circle is touching both the side, all the 4 sides, the diameter and the side will be equal. Okay. So this and this will be equal, and this and this will be equal. So the side and the diameter will be equal. Now every time they will maintain a ratio 4 is to pi. Okay, then only this condition will satisfy, touching all the 4 points, right? Now if you observe in this case the squares are making a series GP, as well as a circle is also making a GP, right? So if you consider them separately, this is actually 2 GPs. So if you start off with the square, if you take, it's actually a square like this, something which we have discussed, right? So that is a GP with a common difference 1 by 2, right? Again, the circle is also like that, because if you add a more circle, I told you this is 4, this is pi, this is 2, this is pi by 2, right? This is 1, this is pi by 4. like that it will go, right? So all these will be in the ratio. This will be like this is 4, this is 2, this is 1, this is half of it, 1 by 2, etc. It will go. Same way if you take the circles, circles will be in the ratio pi, pi by 2, pi by 4, pi by 8, etc. So for 4 it is pi, right? This is how it will work. For 4 it is pi, for 2 it is pi by 2, for 1 it is pi by 4, for 1 by 2 it is pi by 2. In all case, ratio of 4 is to pi is maintained. So you can find the area of squares, the total area of squares. You can find the total area of the circle also based on what we have discussed, right? Because a common ratio is there, right? So here 1 by 2, here also 1 by 2. Common ratio is 1 by 2. So if you know the outer area, that is, let's say A, 1 minus 1 by 2. Same case of this also 1 minus 1 by 2. So you can find the answer faster here, right? Okay, if the first term and the third term is given, okay, let's take 1 as the first term and 5 as the third term. How will you find the second term? This is in an AP, right? So it's like this is A and this is C is given, you need to find B, right? We call it as arithmetic mean or the middle term of an AP, right? Or this is nothing but average only. How will you find it is actually A plus C by 2, right? So this is how you will find the middle term. So what is the answer? 3 is the answer. A plus C by 2. What about 3 terms are there? A plus B plus C by 3, right? So this is what? Arithmetic mean, or simply you will tell average, right? What about a GP? Let's suppose you have 1, 4 is given, you need to find the middle term, right? So if this is A, this is C, this is B, how will you write B? B is equal to root AC or AC raised to 1 by 2, right? So what is that? 2. Root of 4, which is equal to 2, right? What if 3 terms are there? You will write it as ABC raised to 1 by 3. What is harmonic progression? I will discuss that in detail when it comes to speed distance time, right? So harmonic mean concepts and application we will discuss in speed distance time, because you will see questions like average speed, right? There you will be using, see, in different situations you will use 2 different aspects. Either you will use, see, the question is something like this: you are traveling from A to B, okay, you are going to B and you are coming from B to A, right? On first this you are going at 40 km per hour and you are coming back at 60 km per hour, right? So here if you see, the distance is constant, right? Distance is same, you are going and coming, right? Same distance. So in this case you need to find the harmonic mean of speeds. Harmonic mean of speeds is what your average speed, right? So how will you get that? 2AB by A plus B. That is nothing but 2 divided by 1 by A plus 1 by B, right? So what is harmonic mean? Harmonic mean is actually, if 2 terms are there, 2 divided by 1 by A plus 1 by B. If 3 terms are there, 3 divided by 1 by A plus 1 by B plus 1 by C. So here in this case there is an application of harmonic mean. So if you find the answer, you will get it as 48. You will get it as 48. So where you are applying harmonic mean? When the distance is constant. If you see, otherwise if time is constant, or for the first 1 hour you are traveling at 40 km per hour and the next 1 hour you are traveling at 60 km per hour, then what is the average speed? Average speed is nothing but simple average, right? So 40 plus 60 by 2, that you will get 50, right? So this 50 is actually what? Average speed. You are just taking average. So here 48 is also average speed, but you are taking harmonic mean, okay? Just by seeing average speed, you should not take average directly. Why? Because this is nothing but 40 into 1 and 60 into 1 divided by 2 total. So you are finding the sum of the distance covered divided by time, you are getting the speed, right? So why I am writing 40 plus 60 is basically, this is nothing but 40 into 1, that is the distance covered, plus 60 into 1, that is the distance covered, divided by total time. So distance by time is your speed, right? So that's the application of harmonic mean. So harmonic mean I will discuss in detail in speed distance time. There you will see a lot of applications also. When it comes to average speed, we will solve problems also. So what we have discussed, arithmetic mean is A plus C by 2, geometric mean is root of AC or AC raised to 1 by 2, right? Harmonic mean is 2AB by A plus B. So what all things we discussed? We start off with AP. AP we have seen 1, 2, 3, 4, 5, etc. There is an AP, right? So I told you how to find the nth term, right? A plus n minus 1 into D, right? So how many terms are there if you need to find? you need to know the last term minus first term divided by the common difference, right, and plus 1. Then sum of n terms means n by 2 into 2a plus n minus 1 into d, right? Or you have alternative, if you know the first and last term, n by 2 into first term plus last term, right? So if you know the last term, this is applicable, right? If you don't know the last term, if you know the first term and the common difference and number of terms, this is applicable. What about GP? What is the nth term? AR raised to n minus 1. What is sum? A into 1 minus r raised to n divided by 1 minus r, right? And A into r raised to n minus 1 divided by r minus 1. Okay? So it depends on r value. If r greater than 1, we'll use this. If r less than 1, we'll use this, right? What about sum to infinity of a GP? I have given you the application question also. You have a square, adding the midpoint you get another square, adding the midpoint you get another square, and you keep on adding. So it is an infinite GP. Sum of areas, if you need to find the outer area, that means the first term divided by 1 minus r, right? So in the square which I have told you is 256 was the area, that is outer area first term, divided by 1 minus 1 by 2, that is nothing but 512, right? Arithmetic mean, the middle term a plus c by 2, right? If 3 is there, a plus b plus c by 3. Geometric mean, root of AC or AC raised to 1 by 2. If 3 is there, ABC raised to 1 by 3. Harmonic mean, that is nothing but if two terms are there, 2 divided by 1 by A plus 1 by B. Harmonic progression is actually a reciprocal of arithmetic progression, right? So this is nothing but 2AB by A plus B. Or if 3 terms are there, 3 divided by 1 by A plus 1 by B plus 1 by C, right? This is what we have discussed till now. Now some special cases. See, you may think that AP is nothing but 1, 2, 3, 4, 5, 6, etc., right? So naturally, it is an easy question. Anything can be attempted easily, right? But they can make a really difficult question from here. Let's take a question like this. How many ways you can write 100 as sum of consecutive natural numbers, right? Some consecutive natural numbers means it's an AP, right? So this is again AP related question only. 100, how many ways you can write it as sum of consecutive natural numbers? Okay, so here you need to go for trial and error method, right? So this is just a random question. Otherwise, see, if they are given the starting first term as 18, then it is not a question. You have only one way, right? 18, 19, 20, 21, 22. Otherwise, if you see how many ways you can write, it is a difficult question, right? The other possibility of writing this is 12.5 into 8 is actually 100, right? So you can make 12.5 as average, so 12 and 13 you write first, then 12.5 into 8, right? So write 3 terms here, 11, 10, 9, 14, 15, 16. This is another way. So they can actually make really complicated question. These are the two ways. I tell you the logic and how you are writing this. All these things will be discussed after some time. I'll take up this as a different session, sum of consecutive natural numbers. So you can get a separate session and separate sheet also for this kind of pattern. So this I'll be discussing along with the difference of square pattern, sum of consecutive number pattern, etc. Right? So I'll discuss all the logic behind this, right? Now otherwise, simply they can ask you questions based on first 10 natural numbers, 3, 4, 5, 6, 7, 8, right? What is this sigma n? Sigma n, you learn another formula, right? N into n plus 1 by 2. What does this actually mean? If you try to find the sum of an AP, if you consider this as an AP, what is the sum of this? Let's take n terms are there, right? What is our formula? N by 2 into first term, that is 1, plus last term, right? This is what you got here only, right? This is n by 2, this is n by 2, n plus 1, 1 plus n, right? So both are actually same. So you can get questions based on sigma n, right? We will discuss sigma n also separately because I have many different patterns to discuss, right? It's like some of the page numbers of a book is adding and the person is missing a page and he got some number like 199. What is the page number he missed out? Or the person is adding the page numbers, he added one page extra and he got 220. What is the page number he added? So these are some typical CAT questions that we have seen in the previous papers, right? So I'll discuss this as a separate pattern. Or the question can be asked like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. It is written on a blackboard up to like 30 numbers. Okay, the first person will come. He will cut. He will rub off any two and will add the sum, right? So he will write 3 instead of 1 and 2. The second person will come and take any two off and will write the sum here, right? The third person will come and will do the same process and will write the sum. He keep on doing it till you complete it and finally you get a sum. What is that? So that is also again application of sigma n only. Basically what you need to find is sigma n. Here you need to find sigma 30, right? Because that operation will be performed 29 times and you'll get finally sigma 30 itself. You get the total sum. So all these questions you need to solve by using sigma n. So in that question which I have discussed where the person is counting the page number of a book, he is trying to find sigma n but he is not getting sigma n. How will you solve it? Okay, for example, what you are doing is actually you are counting the page number of a book starting from 1, 2, 3, 4, etc. You are adding a page and what is happening? You are getting a number which is 220, which is not a sigma n number, right? Because you're actually supposed to get a sigma n number here, right? You're counting the page numbers, you're adding the page numbers means 1, 3, 6, 10, 15, 21, etc. These are the numbers that you're supposed to get. Why? Because first page, if you this is for 1 plus 2 you get this, 1 plus 2 plus 3 you get this. If you add 4th page you get this, 5th page you get this, 6th page you get this, like that, right? So he's trying to find these numbers 1, 3, 6, 10, 15. What are these numbers? These numbers are also called as triangular numbers. These things I'll discuss later, right? Why it is called as triangular number? Because you can you can make triangles with this, right? It's like this, you can visualize like this, right? If 10, you can make triangles with these numbers, right? Now another thing which you can see here is if you add these numbers you get square numbers, right? You get square numbers. Why you call this as square numbers? Because you can make squares, right? This is what 16, right? So this is what 9. So the point is he is trying to find a sigma n number, that means 1, 3, 6, 10, 15, 21, etc. Your answer should belong to this series. But what he is getting is 220. Why? Because he is adding a page extra. That means this number don't belong to the series. So what you need to find is, the logic is you need to find the nearest sigma n number to 220. Nearest sigma n number to 220, which is on the lower side. Actually it is 210 because 210 is a part of this. Okay, that means if the book is having 20 pages, right? 20 pages means 20 into 21 by 2, right? So this is nothing but 210. If the book is having 20 pages, you are supposed to get 210, but he counted the 10th page and he got 220. That's how you need to solve. You need to find the sigma n number. That means the number which comes in this series on a lower side to 220. Why on a lower side? Because you are double counting. If you are missing a page, I will take the next number, definitely, next sigma n number. So if you know this sigma n numbers, if you know the series, the question is just a cakewalk. You can see that it is 220. I know sigma n number, that is 210. So the added page is 10 direct. Or you are missing a page and you are getting 200, right? You are missing a page and you are getting 200. I know the nearest sigma n number on the higher side is 210, so I can pick 10 as a page number he missed out. But for that it is very difficult. You cannot remember all the sigma n's, right? So if you can remember, then it is easy. Otherwise what you will do is, what I am trying to do is n into n plus 1 by 2 is what I am trying to find, and I am getting 220, right? I tried to find this value but I got 220. I know this is not correct, but I know this is approximate value because he added one page extra, so I can mark it as approximately equal to 220, right? Now that means n into n plus 1 is approximately equal to 440. So n square plus n approximately is equal to 440. Now compared to n square, n is small, so I can approximate again. N square is equal to 440. Now if you need to know n, so basically you need to find n. If you can find n, you can find sigma n easily, right? So if you find n, it will be between 20 and 21. So it will be between 20 and 21, right? 440 is between 20 and 21. I need to take any of this as my n. Which one I'll take? I'll take 20 because I am double counting. If I was missing a page, I will take 21. I'll take it on the higher side, right? Now, I got n as 20. So after this, what I'll do? I'll find sigma n. 20 into 21 by 2, I get 210. So this is the value which you are supposed to get. But what you got is 220. So which page number you added? You added 10th page, right? So answer for this question is 10. You added 10th page twice. But if the question was something like this, you are adding the page numbers of a book and you are missing a page and you got 200. So you are getting 200, right? You are missing a page and you are getting 200. Now onwards, if you see this kind of question, first step that you need to do is take twice of it. You'll get 400, then take root of it, you get 20. 20, assume this is your n, okay? 20 is your n. You find the sigma n number with 20, you will get 210. So what you actually got when you are counting, you got it as 200. Actual value is 210. So what is the difference? 10 is the difference. So which page number was missed out? 10th page is missed out. Or if the question was you are counting the page numbers, you are missing a page and you are getting 199. What you will do, same step, you don't bother about anything. You understood that you're missing a page, you're trying to find sigma n, you're missing a page and you're getting a different number, right? So take that number 199, take double of it, right? And you get 398, take root of it, you get it between 19 and 20. Okay, so this n value is either 19 or 20. Which one you will take? You have to take 20 because you are missing a page. If you are adding a page, you will get 19. Okay, now by using 20 you can find the actual sum of the page numbers, right? Or actual sigma n. 20 into 21 by 2, you will get 210. So 210 is what you got, what you are supposed to get, but what you got is 199. Why? Because 11th page you missed out. Then now you can get questions based on this also. 1 square plus 2 square plus 3 square, etc, 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 right? How? Like the way they are asking you questions. This is nothing but what is this? This is nothing but sigma n square. And what is the answer? N into n plus 1 into 2n plus 1 divided by 6. Right? Now how can you make a question? Like a person came, he is writing 1, 2, 3, 4, 5, 6, etc. on a blackboard. Right? Another person will come and he will write 2, 3, 4, 5, 6, etc. Another person will write 3, 4, 5, 6, etc. Another will write 4, 5, 6, etc, etc. So finally, if you take the sum, what will be the sum, right? So this is nothing but, here it is 1, here it is 2 into 2, 2 square, here it is 3 times 3, that is nothing but 3 square, this is nothing but 4 square, right? That will be 5 square, 6 square, etc, right? This is nothing but sigma n square. So n into n plus 1 into 2n plus 1 divided by 6. Now there can be questions based on 1 cube plus 2 cube plus 3 cube, etc, etc, right? This is nothing but sigma n cube. What is that? N into n plus 1 by 2. You already know this, right? What is this? N into n plus 1 by 2? That is nothing but sigma n. Take square of it. You will get sigma n cube. Otherwise, you'll get questions like 1, 3, 5, 7, 9, etc, etc, etc. Find sum. Okay, this is an AP with a common difference 2 starting with 1 and it is going on, right? You may get the nth term also, not a problem, right? Assume that you have 9 terms or 1, 2, 3, 4, 5 terms, right? So if you need to find sum, this is nothing but odd numbers, right? Sum of first n odd numbers. That's what the question is. Your answer will be n square. So if n is 5 here, if you see here, n is 5. This is first term, second term, third term, fourth term, fifth term, right? So your answer is 5 square. So 5 square is 25. Now what is 5 square? See, a square number if you take, you can also understand in this way. 5 square is actually equal to first 5 odd number sum. Like this. 1 plus 3 plus 5 plus 7 plus 9. That's how you can understand 5 square in a different way. So if you are finding the sum of this, you can take it as 5 square. Or 5 square can be understood as sum of first 5 odd numbers. 10 square, sum of first 10 odd numbers. 6 square, sum of first 6 odd numbers, right? What is 3 square? What is 3 square? Sum of first 3 odd numbers. 3 square is 9. First 3 odd numbers, 1, 3 and 5, right? So if you add, you'll get this. So a square number can be understood as sum of first n odd numbers. So n square, if you need to know sum of first n odd numbers, or the reverse is what we have discussed here. Okay, if you need to find the sum of first n odd numbers, you take n square. What about sum of 2, 4, 6, 8, 10, etc, etc, even number? So basically this is nothing but sum of first n even numbers, right? There's nothing but n square plus n. So you take sum of first 3 even numbers, right? So 2, 4, 6. I need to find sum of first 3 even numbers. So what is n? N is 3. 3 square is 9 plus 3, that is 12. Okay, let's add this. 6 and 6, 12. So what I need to tell you is sum of first n even numbers, if you need to find, n square plus n. Sum of first n odd numbers is n square. So any square number you can think in this reverse way also. How you are actually getting a square number? If you are finding 100 square, what does this mean? Sum of first 100 odd numbers. So you are actually finding first 100 odd numbers. That is what your sum. Okay, that is what your square. So 15 square is 225. What does this mean? I can now directly see 1, 3, 5, 7, 9, 5. Okay, 11, 13, 15, 17, 19, 10 numbers, right? If you take the sum of it, you will get 5 square. If you get the sum up to this, you get 10 square. Now 21, 23, 25, 27, 29, you get 15 square if you take sum of all this, right? So that is what 225. I hope you understood. So what all things we discussed, the special cases, sigma n, I have told you 2 questions. Anyway, I'm going to discuss a lot of questions based on sigma n. We will discuss sigma n in detail. I'll spend half a session for that, even I'll spend 40 minutes for this discussion in the next session. Okay, then number as sum of consecutive numbers. Okay, so this also I'll discuss in detail. This is nothing but you need to find the number of odd factors. This is nothing but number of odd factors of that number. So if you need to know 100 can be, how many ways 100 can be written as sum of consecutive natural numbers means odd factors of 100. How many ways 60 can be written as sum of consecutive natural numbers means how many odd factors of 60 is there, right? So you know how to find odd factors, even factors, etc. we have already discussed. So 100 is actually 5 square into 2 square. How many odd factors is there? 3 odd factors is there. 60 is 2 square into 3 into 5. How many odd factors there? You avoid 2. 2 into 2 which is equal to 4. So 60 can be written as 4 ways. 100 can be written as 3 ways. Out of that 100 itself is 1 way. So subtract it. You get 2. You subtract it. You get 3. So actually how many ways you can write is number of odd factors minus 1. That many ways you can write a number as sum of consecutive natural numbers. So if you need to answer how many ways 100 can be written as sum of consecutive natural numbers, answer is 3 minus 1, that is 2. How many ways 60 can be written as sum of consecutive natural numbers? 4 minus 1, that is 3. What is 3? Number of odd factor. What is 4? Number of odd factor. So if you need to generalize, number of odd factor minus 1. Then we have seen sigma n square. We have seen sigma n cube. This is nothing but n into n plus 1 into 2n plus 1 divided by 6. This is nothing but n into n plus 1 by 2 whole square, right? We have also seen sum of first and odd numbers as n square, sum of first and even numbers as n square plus n. Okay, now let's quickly see what are the different types of APs and how their sum will look like on a graph, right? So what are the different types of AP? If you see, there are basically you have increasing AP and you have decreasing AP, right? If you need to see AP is 2 different types, increasing and decreasing. Now within increasing itself you can have 2 categories, starting with positive and starting with negative, right? Starting with positive means 2, 4, 6, 8, 10, etc. it will go. This is a increasing AP and starting with a positive number, right? 2. Negative, it will be like minus 12, minus 8, minus 4, 0, 4, etc. right? So this is starting with negative number but it is increasing. Now decreasing means what? In decreasing also you can again see starting with positive and starting with negative, right? See, if you see starting with positive means you can start with 10, 8, 6, 4, 2, 0, etc. This is decreasing GP, decreasing AP starting with positive, right? Now starting with negative you can see like minus 2, minus 4, minus 6, etc. etc. Now same classification is applicable for GP also, right? GP also you can see increasing and decreasing. Starting with positive, starting with negative, here also starting with positive and starting with negative. So basically we need to see 8 different types of 4 in AP and 4 in GP, right? So let's start off with AP. I'll start with increasing AP, okay? And we'll discuss 2 types in increasing AP. Let's start off with a positive number, right? Positive, the AP which is starting with a positive number. Let's start with 2, 4, 8, 6, 10, basic AP, right? Now you know the sum. This is something which we have seen just before, n square plus n and all. You know the sum, but I'll just tell you how the sum will look like on a graph, right? So if you plot a graph and on this y-axis sum and on the x-axis if you take number of terms, it will go like this. So the sum keeps on increasing if the number of terms is increasing, right? Starting with positive, right? Now what about an AP, increasing AP which is starting with a negative number, like let's take minus 4, minus 2, right? 0, 2, 4, etc. right? How will it go? How will it look like? If you need to plot on a graph, right, it will start from negative, it will go to negative, then it will come back, right? Why? Because if you take the first term, this is minus 4, then minus 4 minus 2 means somewhere minus 6, there is nothing but minus 6. Then if you add 0, again same, right? Then you add 2, it becomes minus 4 again, then you add 4, then it becomes 0, then like that it will go, right? Now what about a decreasing AP? Decreasing AP starting with positive, it will look like 8, 4, right? 0, minus 4, minus 8, etc., right? How will it look like on a graph? Here if you see the first term is positive, right? So it will start from positive, go to positive and will come down, because this is 8 first term, right? So this will be 8 plus 4, this will be 12, and if you add 0 it will be 12 itself, right? Then if you add minus 4 it will come back here, if you add minus 8 it will come to 0, like that it will go, right? Then it will take these points, right? What about a decreasing AP starting with negative, like minus 2, minus 4, minus 6, minus 8, etc. How will it look like? It will look like this, right? Because the starting itself is minus, then minus is accumulating, right? So it will look like this. What about GP? Increasing GP starting with positive. You can take 2, 4, 8, 16, 32, etc. Right? How will it look like? It will look like this, right? If you take sum, if on y-axis you take sum and number of terms, the graph look like this. What about increasing GP starting with negative? Let's take minus 8, minus 4, minus 1, 1 by 2, etc., 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 right? See, if you see all the numbers, it is all are negative, right? It is increasing, but still all are negative, right? How is it increasing? If you see minus 8 to minus 4, minus 4 to minus 1, minus 4 to minus 1 by 2, then minus 1 by 4, all values are negative. So it will look like this on a graph. Now after some time, if you find the sum, it will it will be almost same, okay? Approximately the values will be same. Now 1 by 2, 1 by 4, 1 by 8, 1 by 16, etc. If you go towards infinity, these values will be almost same, right? Now what about decreasing GP starting with positive, like 12, 6, 3, then 3 by 2, that is 1.5, right? Then 1.5 by 2, that is 0.75, etc. How will it look like on a graph? If you plot a graph on y-axis sum and on x-axis number of terms, it will look like this, right? Because it keeps on increasing. It will increase, but after some time when it going towards infinity, right, this is going to be almost equal, right? Now what about decreasing GP starting with negative? That is minus 2, minus 4, minus 8, minus 16, etc. It will look like this, right? All are negative, it will go like this, right? This is sum and this is number of terms. So what we have seen is AP, GP, right? Within that, increasing and decreasing, right? Within increasing, starting with positive and starting with negative. Here also starting with positive, starting with negative, right? So in an AP, if it is increasing AP starting with positive terms, it will look like this, right? Starting with negative terms, it will look like this. In a decreasing AP, starting with positive, how will it look like? It will look like this. Starting with negative, it will look like this. Now in GP also you can see increasing and decreasing, and starting with positive, starting with negative, starting with positive, starting with negative, right? Starting with positive, how will it look like? Increasing GP starting with positive look like this. Increasing GP starting with negative will look like this, right? Towards the infinity, the value is almost same. Now decreasing GP starting with positive, how will it look like? Decreasing, so it will go like this, right? Now decreasing GP starting with negative, how will it look like? It look like this, right? It look like this. So let me conclude quickly what we have seen. AP, GP, right? 4 types of AP, 4 types of GP. So total 8 different categories we have discussed, and we have seen the nature of sum on a graph, right? In 8 different types of situations where AP and GP is involved, right? So if it is an AP, if it is an increasing AP starting with positive look like this, increasing AP starting with negative look like this, decreasing AP starting with positive look like this, decreasing AP starting with negative look like this, right? Now if it is increasing GP starting with positive look like this, starting with negative look like this. If it is a decreasing GP starting with positive look like this, starting with negative look like this. So some of the questions, if they are giving you the graph directly and will ask you to identify, okay, they will give you which among the following represent a graph of a decreasing GP which is starting with positive, right? You can directly pick.